So today I want to talk about LLM firewalls. Basically, I talked about this topic a lot, and I know this. But the issue is, I always think that there is a part that is missing, and I don't want these videos to be just watched. If you want, you can, and if you want, you can like and subscribe as you wish. But the goal is to be understandable and to be basically meaningful, not just to create some videos. So we can start to talk about LLM firewalls. So LLM firewalls are basically firewalls for LLM, which is kind of easy to understand. But the issue is, this is a topic that is understood a little bit weakly, or maybe I am thinking like this. Even if it is not weakly understood, I think I can add something on it. So when you talk about some firewall, etc., you're trying to control something and trying to audit and understand and write rules and then block or allow something. Basically, this is what we expect from the firewalls. And the goal is for us to manage this basically. So how we can do this? That's why, to answer this question, how we can do this question, I created a repo. And this is the repo. If you want, you can check it out. So this is an easy to deploy and run repo. Like it is, I will be making it more compact. I will be making it more like you can at the feature. It will be like just running it with Docker Compose and that's all. But now we have extra steps that we will be doing together to show what is happening and what we can do about it. But the goal of this repo is to understand how LLM firewalls work. So that's why I created this repo, and I will be explaining what is happening at the repo itself by using this diagram. So what is happening? The green parts that you see is already written at the repo, so it is done. It is deployed, but if you want to contribute, you can as you wish. So we can start to check. You have a user interface to communicate with the model, right? So you are just prompting something, etc. So this is the user interface part. And we have an LLM firewall engine. This engine is the engine that will be taking your prompt, analyzing it if there's anything problematic, and then it will be basically allowing you to write it or not. And I didn't exactly implement the AI firewall control for the user interface side, but I have already the interface itself. So if you want, you can write the engine, part of the engines that needs to be written for the AI firewall control side. But still, we have the interface. That's why I write it this green, because if I do not write this in green, this should be green either. So yeah. Then you think okay, I implemented this, but not this. Then how it is sending the message to LLM? So it is implemented, but not in a way that is LLM engine is completely finished. That's why it is not green, but white. So yeah. Anyways, we have an interface. We want something from the model, and when we want something from the model, only for the first time, we are inserting the system prompt itself to the request that we will be doing to LLM, and then also we are inserting the tools that we can use to the LLM's context. That has a reason. So when you want to define what LLMs can use, you need to define how it should be using the models, the functions that is defined for the model, and how it will be responding for the how it can use the model. Yeah, I defined it, but also you need to, if needed, define the structured functions, structured outputs, etc. There is different ways to do it, but you can do it inside the system prompt. But also you can talk about with the fifth shot, you can talk about what you want to do. The fifth shot is basically explaining what you want to do with some examples, 5 or 6 examples about it inside the system prompt to teach how something is done. It's not teaching technically, but it is showing how it is done to LLM, and LLM will be responding it according to it. at the theoretical level at least. It depends how powerful your model is, but that is not the point. The point is at the theoretical level this should be the case. Anyways, then we enter all the context, system prompt to define tools, and if you want to define your there can be a lot of things that you can define, like do you want the output chunk by chunk? Yeah, I mean you want to stream the output, or do you want it completely finished, or what is your timeout settings, etc. It depends to the engine, but anyways, it depends to engine what model is run on. So yeah, that is the goal. But anyways, we will be making it basic and we implement it as is. There are some differences, of course. We have different inputs to LLM, to the server side of the LLM that is running the model, but the point is not that part, so we will be continuing. So anyways, LLM had the input, he knows the tools that he can reach, he knows how to respond, what to respond, how to react. We defined all of them at the system prompt, and we have the prompt that is taken by the user, and user prompt is controlled by the engine, so we are good to go. And then model decides to do something. This is just an example. You can define a lot of function calls, and at your implementations you need to define a lot of function calls to have an effective agent to use. This is sometimes called harness, this is sometimes called a different thing, but the main point of this function calls is connecting the model itself with the outside world. So if you give a function call that can reach the database, you give a function call that can reach something, you have a function call that can run some commands and then take the input. So these are the ways to connect your model, so basically making your model a useful thing except being a chatbot, to the real world. So that is how, for example, the codecs or the other harnesses, I don't know, Pi, Cloud Code, or the other harnesses that is written. They have a lot of function calls, they have a lot of different MCPs that is integrated to communicate with the outside servers. So MCP is a different thing that we will be not discussing at this video, but that is how the models are connected to outside world. But the issue is when you have a connection to outside world, you need to control what LLM uses, and also you need to control how LLM is using it. So that's why before, to LLM to basically make any if LLM wants to use that function call, it needs to create an output with tokens. So before using that function call, or inside the function call, you need to control what is the output of the model to use the function. For example, I implemented the database side at the database function call side. So at the database function call side, you need to basically block all writing operations at the database, but you can allow the reading operations at the database. We didn't divide the database as master, slave, etc. So think as a really basic system design at this point. So when model tries to make a query that can change something inside the database, AI firewall should block the response that is written by the model itself, and it should also inform the model itself that the query is not valid and needs to be written from scratch and should not contain anything that can do a writing operation inside the databases. That is the main goal of the AI firewall at this stage. But normally you need to implement something like EDR, but not sure how. There are some GitHub repos. I will be not showing them, but if you're interested, you can write small EDR for agents. I started, and that is probably something that we will be needing at the future. But still, at your own systems, you need to know how of tools works. So this is how it works. Of course, when you deploy the EDR inside the system, it will be not, it will be probably not controlling inside structure inside of the code. So this will be not directly the architecture, but still it will be at the place something like between the function call and the operating system. So still what will be returning to the model will be the warning sign for the model to not use that function call in a way that will be blocked. So still that is the same logic, and you know how you can implement inside your systems, and it will be kind of useful to understand how it works. And yeah, that is how it works basically. But at this style of deployment, you're writing your own firewall, or you can say it your observation system. You can rename however you want, but it is more closer to firewall because you're blocking something, writing rules, etc. So it seems to me like closer to a firewall, because EDR, etc. has a part that is dynamically analyzing everything either. So it is not in a way that is classic observation or EDR. So firewall seems more more sensible for me. So that's why I call it LLM Firewall or AI Firewall. It doesn't matter. The important point is we need to control what model is doing, and at the current stage, models are not just doing prompt like just talking with you. So they can do a lot of things. They can run functions. They can do queries. They can do a lot of things. They can do web scraping, and they are vulnerable to a lot of different type of attacks that can be indirect or direct prompt injection, or like a lot of different stuff that can happen. So to block it, we need to implement a system, something like an AI firewall, and this is how it's implemented. So at the AI firewall, you need to write the kits or the functions that will be interfacing with the function call and the model, and then the kit itself will be checking for the queries at the database function calls interface side, that what is happening and how we can respond. Is it good? Will this query change something inside the database, or is it not a query and it is not acceptable? Anything like that, or is it empty, or something like that. So you are trying to detect the anomaly and block it as soon as possible. And there is different implementations for the script running function call or vector database function call. We will be probably not discussing at the future. We will not probably discussing at future, because the goal of this video is under explaining the logic of how it works. And so yeah, we explain how it works, and then as you can see, if it passes the firewall, it will be giving the context of what database give to model, and then basically model can resend to the user, or basically use this data to use an independent service. And yeah, also this is an important part, because you can integrate your models with different independent services or microservices, which is interesting. They are not the same thing, I know this, but because models are really good at this point, really good at giving structured outputs, they can effectively use different services outside of the context either. So you can basically create a really interesting integrations with the different services basically, which is all up to you and your mind. So you can create a lot of things, but the goal is how the system works. So you understand that what is function call, kinda. You understand that how the firewall will work, and what is LLM Firewall Engine at here, the interfaces, and anything else. And also, like, maybe we can talk about LLM Firewall Engine. So this is not just only writing some regex style rules and then just implementing them. You can implement in a really different way. Also, you can write a lot of different rules. For example, this is a really easy, do not do anything corresponding to write, or a big query that will be creating issues inside the database. This is really kind of logical. But the problem is, when you think about this, this is not only the case. You don't want the PIIs to be outputted to go to outside world, or you don't want the model to reach some information because like least privilege stuff and zero trust principles. So you need to create a really big firewall engine that can dynamically, if it starts to make something dynamically, it will be next generation or it will be something like EDR, I don't know. But you need to implement in a way that it will be give capability for the models when it is deployed to the systems. It is compliant with the regulations and it is accreditable. So that is a very important part for the controls either. Because if you want to integrate something that is not deterministic inside the systems that expect it to behave in a deterministic way, you need to have fallback plans and you need to control what is the model is doing, and you need to do this in a really dynamic way that is auditable and integratable and basically accreditatable. Yeah, we can say like this. So yeah, that is the explanation of what is the LLM firewall and how it works and why it is important and what is the difference. Like, are we just taking what is inputted and then just regexing? No, you understand that it's either. So, but at the basic example we will be doing exactly this, but I will be showing it how it is happening. So we can move to the laboratory. So as you can see, we opened the clean folder to understand what is going on, but maybe the name is not suitable, so I will change it quickly. Good, now you can see that we created an empty folder that is clean. So we will be going step by step how we can yeah, I was listening music at the left. Anyways, so no, we will be not leaving it, but maybe I will be putting this to the files. So you can see the introduction, and then we need to create an environment, but firstly we need to clone. So you can clone as you wish. I like with the you can choose anything to clone basically. What that was the goal. That was what I was trying to say. So anyways, we will be cloning this, and it is cloned basically. So we need to enter it. I guess we can check. So Python M. So we need to firstly enter inside it LLM Firewalls, and then we will be creating a virtual environment as seen as here, and yeah, it's created, and then we can activate it, but maybe for Windows it is different, so let me check. But for Ubuntu this is how it works, at least that's what I remember, but we can try this. We can try. So for Windows we can write like this. So source dot venv dot script scripts dot activate, but it didn't happen for some reason. Okay, scripts s is big. So and activate PS1. So maybe this. Okay, so maybe this will work, not sure. Okay, so I will try this, and it's created it. And yeah, for Windows environments you need to run this, but for Ubuntu, at least at my own Ubuntu, you needed to write this and activate the environment by scripting this. So you will be installing the requirements, and it's installing the requirements. Good. So we can check the repo, and yeah, we need to create an environment. It can be like 1, 2, 3, 4 maybe. So yeah, good. And then we need to start the Docker compose, but do we have the... So our Docker is starting, good. So yeah, now we can run the Docker compose. Okay, I can write. So this is, sorry. So we created the volumes, we can check, or we can check from the Docker PS either. And yeah, we can see that we created the container. Yep, good, and it is running. So good. Inspect data directly. So we can inspect the data by writing this. And we need to, from, I don't know, customers, yeah, customers, and you can see. So good, we inspected it, and then we need to run the Ollama, but I am not sure what I have inside my Ollama. So we have Quen 3.6, the Quen 3.5, I don't have it, but should I have it? Or we can check the environment files, but we did not do this in a dynamic way. So we can do something like this. Sorry, I'm just checking. At here you can, yeah, good. So at the arguments, at the default, when you run the program, it will be running based on Quen 3.6, but at my Windows side I don't have Quen 3. Oh, I have Quen 3.6. Okay, anyways, good. So it runs Quen 3.6. So we can check, does Ollama serve? And it is already serving, good. And then we can run. So yeah, we can, good. So basically we now set up all the program that we want to run, and we can ask, for example, run me all the customers. Oh, for some reason we have 404 and it is not allowed for some reason. We can check again the Ollama serve. So maybe at the Docker side it is already taken or something like that. Not sure. No. So now we can check the Ollama, maybe. Maybe is it running or not? I don't know. So Ollama is running. When we send a curl request, like it's not curl but probably get request, it says it's running. But when we had some issues, we were not able to. So I am just So we can try it again. So hello. So we can write exit and we can run it again. So we write it Quen 3.6, but maybe we can change the main and we can do something like this. So when you write Ollama ls, you have this one, right? So we can copy this and then write to here. And when we write exit and when we write hello, it will be responding that. So yeah, now we will be waiting the response of the model. But normally Qwen 3.6 latest is the 35e, so it should work normally, but it did not for some reason. So yeah, it is a big model, so that's why we need to wait a bit, I guess, so we can check how much is taking from us. Yeah, it is taking a little bit, as you can see. It takes a little. So yeah, it's a big model, so I don't recommend you to use Qwen 3.6, but it is in default is Qwen 3.6, and you can change as you wish. And yeah, that is how you can do something. But I was using Qwen 3 when I write this for the first time. That's why it is like Qwen 3. And you can change as you wish, but at the future I will be updating the repo based on how, like based on, for example, you will be able to write what model you want at here, and it will be enough. But for now it is not configured in a way that you can do it. So yeah, good. I want all customer information. As you can see, database firewall is activated, and probably it used a select query, so it's allowed for the query to run at the database side. And as you can see, we had the information, but if we say change lens mail to some on my gmail.com, if we write this, then it will be blocking it because it will be using update or something like that. So firewall, yeah, as you can see, it's blocked. So yeah, that is the important part, and that's why you need the firewalls either. This is a basic demonstration of why you need the firewalls, but still it's kind of effective because probably you will be writing function calls that is directly connected to database, etc. So it's important, yeah. We will be waiting for the answer. I am currently unable to update customer infrastructure of the interface due to security restrictions of on-write operations. So that is so he gave me the query, but still it is blocked by the firewall, so you can run by your own if you want. So we can exit. Good. So that is all for today. I hope it helped, kinda. And yeah, I need to make some updates at the repo, but it is still kinda, I think it is kinda useful to have this type of example to see why we need it, and basically to learn. And if you want to contribute, I will be more than happy to see your pull requests, and see you soon.